Hello, welcome to AMP Unit 7 Power Transmission Belt Drive lesson. This slide shows the type of power transmission elements available in the market. Well, we have an electrical motor which drive the pulley with a V-belt drive and through a reduction gear and transmit the drive power through a chain drive to a driven machine. Sometimes you can have a direct drive from a V-belt to the driven machine. So in this chapter, we are looking at the V-belt drive. Belt drive selection. This chapter, we also look at the calculation for numbers of belt needed for a system. By the end of this unit, you should be able to design a V-belt drive system, determine the design power, and select the proper V-belt cross-section. Select a pair of standard sleeves and the belt pitch length. Determine the number of belts required for this particular problem. Belt drives are used for transmission of power when the center distance between drives are relatively large and need not be very precise. That means you can have some play. Belts are machine elements that use friction for the transfer of energy. Belt drives can absorb shock and vibration and are relatively quiet as compared to chain drive. Types of belts available in market. The most common, simple and least expensive will be flat belt. A flat belt can be used at high speed but at lower power setting. V-belts, the belts that we will be looking in for this chapter, where it can be used at higher power setting at a speed ratio 7:1. Ribbed belts, they are used where light duty power required, can operate at a higher speed ratio of 30:1. Timing belts is a constant angular velocity and is one of the special belt design where it does not slip. Link belts, center distance is not crucial. So as mentioned, there are various types of belt designs available in market driven by pulleys. Right. All belts come in standard pitch length, and that is dictated by the center distance between your two pulleys. These slides talk about chains. So power transmission chain transmit power through interlocking of drive and driven sprockets, while belt itself utilize pulley and frictional force. So of course, chain will be used where loads are heavy, all right, and moving parts by pulling conveyor chain. So we will compare what is the advantages of belt drives over chain drives. Belt drive, right, it will absorb shock and vibration. Maintenance is much more simple as compared to chain drive where it requires no lubrication. Relatively low cost as compared to chain drive. Okay, and the flexibility of the design where the positioning of the pulley need not be so concise and you can twist the belt as shown here in the diagram. This slide talks about the advantages of chain drives over belt drives. It has high efficiency, permits smooth and efficient flow of power. The efficiency can be as high as 98%. Positive drive, no slip, and therefore greater power of capacity. Normally used in automobile valve, timing, and printing machines. But if you were to recall back to earlier slides, there's one type of belt that provides positive drive as compared to others. Most of the belt drives does not provide positive drive. That means it tends to slip at times. But in this case, this particular belt is used in automobile valve timing. Can you think about it? Well, the belt name is called timing belt. So timing belt gives a positive drive as compared to others. Okay, chain drive can be operated in oil, surround, or high temperature environment where the belts will not be suitable. And a single chain can drive many shafts at different speeds. Alright, and it can be driven on both sides. V-belts. V-belt is subjected to tension, bending, and centrifugal forces. Thus, a belt must be strong in tension, be pliable for bending about around pulley, be light in weight, have elasticity to absorb shock during motor startup, example, and lastly, provide sufficient friction against pulley. So you can see from this picture, this is a typical V-belt setup with two sleeves of pulley. And if you were to count the numbers of belt used in this system, it will be three V-belts. Alright, so you will have that. How many belts will you require? In the subsequent chapter, we will talk about V-belt selections. Okay, V-belts are operate best at belt speed between 8 and 30 meter per second. Ideal speed is 20 meter per second at a speed ratio of 7:1. So this is a typical cross-sectional V-belt. Alright, so you will have a cover, a load carrying section, compression section, flexible top section. Alright, so this is a typical V-belt layout. Nomenclature of a pulley. These slides talk about the pulley terms, and you can see that a V-belt is seated on the pulley top. Alright, so over here, this is the cross-sectional view of a pulley. Okay, you can cut away this pulley and you look at this position from here, this direction. Okay, from this direction, what you will see will be this. So the top part here is known as outside diameter. It's the largest diameter for the pulley, while the one we're very interested in this case will be pitch diameter. It is one of the variables for us to calculate the actual center distance. Okay, the pitch diameter is used to calculate and select the belt pitch length, and lastly, you also use for your belt power rating setting. You will understand pitch diameter more when we come to the example of the calculation. Alright, so in this case, from this cross-sectional view, I know that this pulley is able to take in 3 V-belts. Alright, 3 V-belts. So how many belts are required for the system will depends on your power rating. Alright, and the power. Okay, so these are the types of pulley and sleeves for V-belt drive. Alright, nothing special, just fabrication methods different. Alright, and let's move on. So subsequently, we are going towards selection of B belt calculation using catalogs. So you will require the appendix given. Okay, you need to download the appendix from the blackboard, all right, or from there. Take note that the given power requirement can be horsepower or kilowatts, but in this case, the catalog utilize horsepower. So if it's given a kilowatt, you have to do a conversion. All right, and most of the time you will be given the revolution per minute of the driver machine. That means the power source, okay, the motor, and the driven machine, the output, and approximate center distance of the drive. Approximate. So these will be the variables given to you, and most of the time these variables questions will, based on these variables to ask you to calculate number of belts needed. In this case, from this diagram here, we know that 2 V belts are needed to drive the machine. So the steps will be as follow for the calculation. First, we will determine the design power, and we will select the proper V belt cross section, which can be section A, B, C, D, I think to E. Okay. Okay. Different section determine the cross sectional area of the V belt. Okay, and determine the speed ratio. Select the standard sleeve or pulley diameter. In this case, we use the pitch diameter. All right, the standard pulley diameter is a pitch diameter for item 4. So after you selected the pitch diameter, then you determine the actual output speed. All right, then determine the standard pitch length of the belt. Okay, standard pitch length of the belt. Okay, so this dictated by your center distance, your actual center distance between the center of the two pulleys. Okay, so the center distance will actually determine your standard pitch length of the belt. Vice versa also, and determine the number of belts. From there, how do you get the number of belts will be the power correction factors, the power rating per belt, and lastly will be your design power. Then from there, you will able to obtain number of belts. You may sound kind of a lot of variables to use, but once you practice and work on the tutorial, you will understand more what we're talking about. Right, we have come to the end part of the belt drive intro. We will move towards a calculation belt drive example. There's one example, but it's broken down into various PowerPoint slides for ease of studying, and also for you all to do your revisit again of the videos. So we will cover belt section, pulley sizing to determine the pitch diameter, the belt length and center distance to calculate these two variables, right? And to calculate the power rating per belt and determine the correction factors. And lastly, from there we were able to obtain the number of belts needed for this particular system's example. Then lastly, we'll run through the summary, and that should conclude the belt drive selections.